Hello and welcome back to the course. In this module, we are analyzing the restore points in Windows, another forensic essential. Attackers are continually hiding their malicious code, erasing and modifying log files, and finding new techniques to minimize the trace evidence they left behind. Forensic examiners can review system restore points to establish an event timeline and discover well-hidden clues that can assist in understanding how a computer system had been compromised. Before that, here's a pre-assessment question for you. What is the purpose of system restore points? Is it A. to provide an opportunity to restore deleted files during a crash or crisis? Or B. to provide an opportunity to restore critical operating system and application files during a crash or crisis? Or C. to provide an opportunity to unhide hidden files and applications during a crash? Or D. none of the above? The answer here is B. Let's see why. System Restore first appeared in Windows Me and was further refined in Microsoft Windows XP Home and Professional. The process is meant to provide the user an opportunity to restore critical operating system and application files during a crash or crisis. System Restore monitors changes to the system and various application files and provides a simple and immediate recovery to various points in time through the creation of restore points. Its value can also be used in the forensic area. Restore points may contain the key piece of evidence to support an investigation, but are commonly overlooked. Content within restore points can be a piece of history to leave behind for an attacker, exposing code, configurations, and log files. Many times, these files can be found even after attempts at counter-forensics, such as long wiping, time or date stomping, and secure deletion. The restore point creation process is enabled by default and happens automatically, so it is very likely that they can be found on a compromised Windows XP professional system. System restore point creation is triggered by one of the following events: the initial boot of Windows XP, every 24 hours of uptime, before program installations, before automatic updates, before a restore point restoration, before an unsigned driver is installed, before storing backup data using the backup tool, or manual creation. A GUI exists for the creation and management of system restore points. It can be found under the Start, Programs, Accessories, System Tool, and System Restore. This interface provides administrative control over many of the monitoring activities. Registry Hive and specific files are copied into restore points upon creation. Not all files are copied after a change. However, file selection is ruled by include and exclude statements in filelist.xml, which is a file located in the C Windows System32 restore directory. This XML file guides the restore point creation process and dictates which file extension will be monitored. Also, contained in this list are the directory inclusions and exclusions. So it is important when reviewing system restore points that you first check the file list XML for a comparison with the default values to rule out tampering. Contents most appropriate to support an ongoing investigation are registry snapshots, file snapshots, or file metadata. Analysis of registry snapshots over the course of time can be a very fruitful piece of evidence and is useful across several different types of investigations. Snapshots of the registry can show system changes such as the installation of hardware and software, program configuration changes, password changes, and network history. The registry is vast in its information, so the list is endless. File snapshots are also important. An example of files you will find in restore points include exes, DLLs, inis, and a very large list of other extensions most users are not familiar with. These files can be copied into restore points without the attacker knowing it. Some counter-forensic efforts and techniques can be prevented by the creation of a restore point which captures the attacker's tools before they are securely uninstalled after the attack. Files that you will not find in restore points are user-specific files such as docs, PDF, and PSTs. Various log files including Windows event logs are also not included in restore points by default. File metadata or file attributes such as the last modified, last accessed, and last created times are not altered during the creation of system restore points. The MAC data on the file is transferred intact to the RP folder. Metadata associated with files can add in the creation of an event timeline and allow a better view into the actions that have taken place on the computer. MAC analysis can quickly identify files related to an incident by comparing MAC times of known malicious files to unknown files. It can show when files were introduced to the system or when they were changed, and help identify a time frame of the attack. So, now we know the basics about Windows restore points, the content and how are they created. In the next video, we are going to analyze the file structure of system restore points, which can help when performing a forensic analysis over a machine. Please don't forget to check the references and supplementary material for more information. Hi, welcome back to the course. In this module, we are analyzing the restore points in Windows, which is another forensic essential. We have analyzed the creation process, some of the content, and what the system restore points are. Now, let's see some of the file structure of the system restore. The system volume information directory can be found at the root of all XP system drive regardless of the state of the system restore. On a running system, this directory and its content are restricted to the system level access by default, but it should be known that alteration of the data is possible by simply changing the rights of the file to include administrator or user level access. The _restore followed by a system identifier resides inside the system volume information directory. This directory exists only when system restore monitoring is enabled and contains the list of previously created restore points. The restore points folders are appropriately named RP, followed by numbers sequentially assigned to folders. This directory also contains _filelist.cfg, which is a binary file that contains the list of the monitor extensions and excluded directories found in filelist.xml that was mentioned in the previous video. The RP directory is the storage location for all monitor files that change between the creation time of the restore point and the creation time of the previous restore point. The system restore process copies new and changed files matching the included extensions into this directory and renames them. An example of the naming convention used is presented in the slide. The numbers increment by 1 as files are added to the restore point. The file extensions are kept the same. A log of these files and their original names and location from which they were copied are kept in a change.log file in this directory as well. The snapshot directory is a subfolder in the RP directory. Here you will find exact copies of the registry at the time of the restore point creation. The changelog is the tracking repository for all files saved through the restore process. The information contained in the file includes the file's original location in the system, the original name of the file, and the name of the file it has been changed to. The difficulty lies in retrieving this information in a usable format. The file is stored in a binary format and can be spread across several change.log files for one restore point. So, finding the one which has the information you're looking for can be a tedious task. The data is most easily readable in a hex viewer. There are several configuration options available to change the usage of restore points. These are stored in the registry under HK Local Machine, Software, Microsoft, Windows NT, Current Version, System Restore. This key contains subkeys such as Disable SR that will allow the user to turn off System Restore. Turning off System Restore monitoring will remove the System Restore points from the logical file system. Create first run RP that determines whether or not a restore point is created when System Restore is turned on for the first time. This percent is the percentage of disk space in megabytes allocated to System Restore. dsmax is the maximum allowed disk space. System Restore uses the larger of the two. dsmin is the minimum amount of disk space in megabytes required for the system restore to be running. Restore status indicates whether the last restore process failed. By default, restore point size is limited to 12% of the drive space on drives larger than 4 GB and 400 MB on drives smaller than 4 GB. Size is further limited by the amount of free space on the drive, giving priority to the system, not to the restore points. As restore points fill 90% of the allotted 12% drive space, System Restore will delete restore points on a first in, first out basis, until only 75% of the 12% allocated drive space is used. This configuration can be changed in the GUI application mentioned or in the registry. Okay, here's a quick question for you. Which subkey of the System Restore key will allow the user to turn off System Restore? Do you think it's A, disable SR, or B, create first run RP, or maybe C, Dix%, or D, restore status? If you said A, you are correct. Turning off System Restore monitoring will remove the System Restore points from the logical file system. In this module, we have analyzed another of the Windows Forensic Essentials, the restore points, which are meant to provide the user an opportunity to restore critical operating system and application files during a crash or crisis. For a deep understanding and more information, please check the references and supplementary material, and in the next module, we'll be analyzing the recycle bin as a forensic essential, the definition, why it is important, and how to find it. Hello and welcome back to the course. So in the previous modules, we were analyzing some forensic essentials or key points that you should look for when examining a forensic image or a live system. We have seen security identifiers, the system registry, the Windows prefetch, and restore points. In this module, we are going to study the recycle bin, which some researchers describe it as a gold mine for gathering evidence and clues. By analyzing the recycle bin, you can recover useful data. The recycle bin, sometimes called recycler, recycled, or $recycle.bin, depending on the version of Windows, is nothing more than another folder in Windows. Users will commonly respond that they deleted a file when what they really mean is that they send the file to the recycle bin. When a file is deleted in the Microsoft Windows operating system, it doesn't delete it permanently. It is stored in the recycle bin. If a user wants to restore the deleted file from the recycle bin, it can be done. If the user holds the shift key at the time of deleting a file, then the file will be deleted permanently without being stored in the recycle bin. In this case, the file is moved to a hidden system folder where it is renamed and stored until further instructions are given as to what is to happen to the file. To understand how the information files are structured and how the naming convention works, there must first be an understanding of how the recycle bin works. When a user deletes a file in Windows, the file itself is not actually deleted. The file at this point is copied into the recycle bin system folder, where it is held until the user gives further instructions on what to do with the file. This location varies depending on the version of Windows that the user is running. The table here shows locations from Windows 95, 98, and Me, where the location of deleted files was in the folder named Recycled, and Windows NT, Windows 2000, and Windows XP, where the recycle bin was named Recycler, and Windows Vista 7 and 10, where the recycle bin is called $recycle.bin. Windows Vista and above now use metadata information to store the selected files and folders in a recycle folder called $recycle.bin before being permanently deleted. Windows XP and below users will have differently named recycle folders on their drive called either Recycled or Recycler. When you delete a file in Windows XP Explorer or My Computer, the file immediately appears in the recycle bin. This is what you see, but actually there is something going on in the background. The complete path and file or folder name is stored in a hidden file called info2, which is inside the recycled or recycler folder. This file is very important because if info2 gets corrupted or removed, normally anything currently in the recycle bin could be lost unless you try to use a piece of data recovery software to get it back. Info2 acts as an index and repository of information about files sent to the recycle bin. It contains entries identified by index number which describe the original file size, full path name, and size of the deleted file. In Windows XP, when files are moved to the recycle bin, they are placed within a hidden directory named Recycler SID, where SID is the security identifier of the user that performed the deletion. The files are renamed to begin with a D, presumably for deleted, followed by the drive letter where the file previously resided, an incremented number, and the file's original extension. Although the file's name is changed, the data's physical location on the disk, its size, and code are unchanged, and the file can still be opened or viewed. Each file moved to the recycle bin gets its own record in the info2 file, with each record being 800 bytes in length. These info2 file records contain important information that examiners can analyze and use in their investigations. Some researchers have found that in Windows 7 and Vista, Microsoft stopped using the info2 file and completely changed the way files were named and indexed within the recycle bin. Firstly, the new recycle bin is located in a hidden directory named $recycle.bin/SID, where SID is the security identifier of the user that performed the deletion. Secondly, when files are moved into the recycle bin, the original file is renamed to $R, followed by a set of random characters, but maintaining the original file extension. At the same time, a new file beginning with $I, followed by the same set of random characters given to the $R file and the same extension is created. This file contains the original file name and path, the original file size, and the date and time that the file was moved to the recycle bin. All of the $I files are exactly 544 bytes long. The behavior is a bit different when you move a directory to the recycle bin. The directory name itself is renamed to $R followed by a set of random characters, but the files or directories under that directory maintain their original names. A $I file is created just as when deleting an individual file that contains the original directory name, date and time deleted, and size. When using the information contained in the $I file for forensic purposes, you can see that all files found under the $R directory structure within the recycle bin were deleted at the same time. If a file was previously deleted out of the now deleted directory, it will have its own $R and $I files and not be grouped with the files that were deleted as part of the directory deletion action. Unfortunately, unlike the info2 file, the new $I files are not in plain or readable text. In order to decode a $I file, you could use a forensic tool that has the ability to interpret these files such as $I parse, encase, and ftk, or you can simply open the file in a hex editor such as WinHex. The file is structured as follows. Bytes 0 to 7 is the file header, always set to 01, followed by 7 sets of 00. Bytes 8 to 15 is the original file size, stored in hex in Little Endian. Bytes 16 to 23 is the deleted date and timestamp represented in number of seconds since midnight January 1st of 1601. Bytes 24 to 543 is the original file path and name. In Windows 10, the contents are still split into $I and $R files, but the organization of the $I files are slightly different. $I files from Windows 10 recycle bins vary slightly from those in Vista through Windows 8.1. The change is not significant and provides us the ability to distinguish between $I files originating from a Windows 10 system and those originating from a Windows Vista 7, 8, or 8.1 system. This piece of information could be important in some instances. For example, if you encounter a $I file in the unallocated space of a Windows 10 system, you could determine if that file was an artifact from a previous non-Windows 10 installation. The difference between the Windows 10.i file and those from previous versions of Windows is detailed in the table. As you can see, the only structural change in the Windows 10 version appears to be the addition of the file name length field at offset 24. This will typically result in $i files from Windows 10 system being smaller than in prior versions, since the $i file is only as large as it needs to be. In previous versions, each $i file was a static 544 bytes, while non-structural, another change can be found in the header version fields. The header field for Vista 7, 8, and 8.1 is hexadecimal 01, while this field is hexadecimal 02 for Windows 10. This makes it very easy to distinguish between the two versions when parsing. Okay, here's a quick question for you. Where can the deleted files be found in a Windows Vista environment? Do you think it's A, in C, recycled info2, or B, C, recycler info2, or C, $recycle.vim, or D, C, $recycler.vim? If you said C, you are correct. A corresponds to the location of deleted files in Windows 95 and 98 and ME. The answer B is the locations for Windows NT and XP, and D is not an existing location. To sum up, despite the changes to the different versions of Windows, to most users, the recycle bin keeps on doing what it was originally designed to do: store files that have been deleted from each user account. Looking at what is in the recycle bin is part of almost every forensic examination, which implies knowing where to find the deleted files and how to understand the metadata associated with the file's deletion. Please don't forget to check the references and supplementary material, and in the next module, we'll be analyzing some pertinent files that must be checked in a forensic examination. For instance, how to extract information from Office files and some tools that will allow you to do that. Hi, welcome back to the course. In the previous modules, we were reviewing some Windows Forensic Essentials, or key points where every forensic analyst should look to find evidence. This is something common in every Windows machine. Now, in this module, we are going to analyze and see how to review some common type of files, such as Office files, pictures, and browsers files. This is important as Windows usually comes with a default browser, photo viewer, and Office suite. Microsoft Word forensic analysis is something that digital forensic investigators do quite often for document authentication. Because of the great popularity of Microsoft Office, many important business documents such as contracts and memoranda are created using Word. Some of these documents may become key evidence and subject to forensic authentication. Microsoft Word saves information about a document in addition to the actual contents of the document. This additional information is called metadata, from the Greek meta, meaning higher or beyond. This includes who created the document, on which machine it was created, who edited the document, and whether the document was saved under a different name. We can use document metadata parsers such as AntiWord, CacDoc, FITools, among others, to review this information. Or in Microsoft Office Word, we can go to the menu File, and under the Info option, we could be able to see information about the file. Every picture file has information embedded about how the photo was taken. This information includes the original picture creation date and the type of camera used to take the photo. This is very important for the cases where we can link a picture to a crime scene or to a device found in the crime scene. This metadata can be found in pictures, audio, or video files. We can use specialized tools to extract this information. There are some useful and very easy to use tools for metadata analysis on images, such as EXIF tool, which you can download in your Windows operating system and analyze the image fingerprint just by dragging and dropping the file into the application icon. EXIF stands for Exchangeable Image File Format. Most modern cameras store EXIF data in every photo file they create. EXIF data is metadata. Basically, it stores the camera settings used to create the picture and the time and date it was created. There are online tools as well which will allow you to see this metadata without downloading anything to your computer. We will see more about this in the next video. Many users think that it is impossible to find out which websites they have visited when they delete the cache and the history. This is not true. There is a file on the system that collects information about websites and cookies. In Windows 7 and earlier, Internet Explorer 9 and earlier used the index.dat to index all this information, including the internet cache, cookies, and history. Every URL and every web page that is listed there was indexed. The information is retained even if the user decided to delete the browser cache and history. Not only that, but all the email that had been sent or received through Outlook or Outlook Express also gets logged in these index.dat files. These files were to be found therefore in the internet cache, cookies, and history folders. You will need a specialized program to view the content of index.dat files. Tools such as Pasco by Kit Jones, index.dat scanner, or index.dat suite are tools that can display the information stored in those database files in Windows 7 or earlier. However, things changed with Windows 8 and 10. In Windows 8, index.dat files are not used by Internet Explorer 10. The indexing function is being implemented within a Microsoft database system. The file named webcache.vo1.dat is located in the folder within the system partition Users, Username, App Data, Local, Microsoft, Windows, Web Cache. The software ESE database view developed by Nearsoft can be used for browsing the database content. Okay, before finishing, here's a quick question for you. When analyzing a picture, what is EXIF data? Do you think it's A, information about the camera settings used to create the picture and the time and date it was created? Or B, information about the operating system used to analyze the picture? Or C, a tool for analyzing the picture's metadata? Or D, none of the above? If you said A, you are correct. EXIF stands for Exchangeable Image File Format, and modern cameras store EXIF data in every photo file they create. So, we have analyzed how to review some important files that you probably will encounter when performing a forensic analysis. Now, let's see how to do this by performing some hands-on exercises. Don't forget to check the references and supplementary materials, and join me in the next videos where we will be doing some labs. Hello and welcome back to the course. In this lab, we are going to analyze the content of webcache.vo1.dat, a database file that stores cache, history, and cookies information in Internet Explorer 10. We will use ESE Database View, a tool developed by Nearsoft, which is a utility that reads and displays the data stored inside the Extensible Storage Engine database. You will need a Windows 8 or 10 operating system environment, a web browser to download the tool, and a zip reading program such as 7-zip, WinZip, or WinRAR. First, you need to log in into your Windows machine and open a web browser. I have in here Google Chrome on a Windows 10 environment, but feel free to use any browser. Search for ESE Database View, or you can go directly to the website in this guide. Download the tool and save it and unzip it in your computer. Go to the folder C Users, Username, App Data, Local, Microsoft, Windows, Web Cache. Copy and paste the file webcache.vo1.dat into the folder where the tool is located. Note that the operating system may be using this file, so you probably will have to finish the process that is using this file in the Task Manager. Open the executable ESE database view.exe. In the main window, select the menu file and click on the option Open ESE database file. If you weren't able to copy the file and are trying to open your local web cache file, click on Open Locked IE10/IE11 database and skip to the step 9. Select the file webcache vo1.dat that you previously copied. Now you will see the table with visited URLs and not only the information about the containers but also the path to the files with the data. The information about visited web page is contained in the containers 2, 14, 15, and 21. It should be mentioned that the information about web pages that a user has visited in the in private mode is contained in the same container. These pages have value 8 in the column flags. Information about users' downloads is stored in the container 22 that has the name IE download. To export the data displayed, click on the menu file in the option Save All Items. Take a moment to analyze the information in the file and answer the questions in the guide, such as what was the last visited URL and if the user visited any site in the in private mode. We have analyzed how to review the information from the web browser as part of the pertinent files that every analyst should check in the examination. Don't forget to check the references and supplementary material, and in the next module we are going to analyze some Windows artifacts that are essential when performing a forensic examination.